So in this video, I'm going to explain about the extracting the minimum key in a binomial heap. So what is the meaning of here extracting the minimum key from the binomial heap? It is going to follow three things. While extracting the minimum from the binomial heap, three things it will going to do that. First they will do that find the minimum key. Then after second step, what it will going to do after the minimum, delete the minimum. Delete min. So whatever the minimum value they will get after the finding min, they will delete it, and third step will perform that union method. So three things we were doing here, and here extracting the minimum. Why so? Because we were working on here is min binomial heap. So here working on the minimum binomial heap, that's why I'm going to extract first min and then after delete it, and then we'll perform the union method. So I've already said that in the previous video, so while you performing union method or inserting the element in the binomial heap, what we were doing, we were following the min heap property, and in that in a min heap the root is always less than equal to their children. Root will be the less than equal to their children. So we already know that all the minimum value at root node, all the minimum value at root node. And one more thing I have already said, that how many binomial tree possible in a binomial heap, and that is nothing but the number of node, and if we convert it in the binary bit, that will be nothing but a log base 2n bit. So maximum binomial tree is possible log base 2n. So we will going to find the minimum from this list. From this list we will going to find the minimum. So start from there. This is the, they will apply here linear search, because this is the one list with the all the root value. So they will start checking from the starting onwards. Is this minimum? They will compare 12 with the 3. Then we'll check that 3 is the minimum. Then we have to come here, then check that another root, is this minimum? So out of that we'll see that this is the minimum one. So 3 is the minimum one. Then what we will going to do? So 3 is the minimum one. Then what we will going to do? First step, what we are saying, that first find the minimum we got that, and that value is 3. Then second, what we will doing, delete the min. So now I am going to delete this 3. If I am delete this 3, what happen is that their connectivity also deleted. This is also deleted. Their children connection will be also deleted. Now what you are getting after the deleting, you will get this this tree. Separate all these 3 become the separate tree. Now what we will going to perform, third step, what I say, that will perform the union, right? So this 12 is going to connect with the 6. This 12 is going to connect with the 6, and this is become the separate. So for that, now we'll arrange this. This is not a binomial heap. We have to arrange this one in a increasing order of the degree, because binomial heap property is saying that we have always the order degree of the binomial tree should be in increasing order. So here look at that, this is 0, this is 1, and this is 2. This is in decreasing order, right? So we'll arrange this binomial heap. Sometimes we will get the direct increasing order, sometimes might be there is a this left children is having single children and this is having 2 children. So like that sometimes you will get. Sometimes if you not got, then you have to arrange this. So this is become one binomial heap, this is become one binomial heap, and this 12 and this 6 is connected. So this is become the another binomial heap. This is become the H2, and afterward, after this division, we will going to perform union. So this is the method of the extracting the min. Now we'll see that each and every step, then how we perform the union, and how we'll get the final binomial heap. So coming to the here, I have just created that this is I have just merged 12 to 6. So this is become H1, and that there all the children, the third I have deleted, the minimum key I have deleted. I have just connected all 3, and I have also arranged in the increasing order degree. So this is become B0, this is B1, and this is B2. So this binomial has become the H2. So now we have a two binomial heap H1 and H2. Now we will going to perform union between these two binomial heap. We will going to perform union between these two binomial heap, and in the union, in the previous video I already explained about the union method. In the union method also we were performing that some steps. So first step is that simply we were performing that merge. First step simply we were performing the merge. Second step what you are doing in second step, in the second step what I am doing that wherever the whichever the binomial tree degree same, whichever the binomial binomial tree's degree is same, then what we will perform, we have to link both. We have to link both binomial tree on the basis of their min heap property, because here I am working on the minimum binomial heap. So according to the minimum min heap property we will going to perform merging, right? So I have here I have two binomial heap. Now I am going to perform union method. So if after the union, first step what you are saying that simply we have to merge both binomial heap tree in a increasing order. So I have simply merged that both binomial tree, and after the merging we got this, after the merging you got that this binomial heap, right? So I got that binomial heap and their all degrees is in increasing order. This is B0, this is B0, this is B1, this is B2 and this is B3, right? I have merged, but problem is that this is not a valid binomial heap, because there is a two binomial tree is having same degree, right? So this is not a valid binomial heap. Then what we will going to perform, what the second step is saying that the binomial tree's degree is same, then we will perform the linking operation. We will merge both binomial tree on the basis of the mean heap property, right? So if you observed here, this both binomial tree is having the same degree, then we will check that which binomial tree is having the minimum value, that will become the root, and the other is become the leftmost children. So after that we have merged this. After the merging I got this binomial tree. After the merging I got this binomial tree. Now again you observe that there is a two binomial tree. This is the B1 and this is B1. There is a two binomial tree is having the same degree. Then again we'll perform merge. After the performing merge, again we have to check that which binomial tree's root value, is smaller, means minimum. So this 7 is having the smaller, so 7 is become the root, and the 12 is become the leftmost children of the 7. So after the merging I got this answer. Again you observe, after the merging I got this binomial heap, but again there is this binomial tree is having B2 degree and this is also having B2 degree. Again this two binomial tree is having the same order, same degree. Then again we'll perform merging. Again we'll check that which root is having the smaller value. So 7 is having the smaller, so 7 is become the parent and 15 is become the leftmost children of the 7. So look at that, the 7 is the leftmost children of the 15. So after the merging I got this binomial tree, right? Now again you check that this is B2 and this is B2. Again this two trees having the same degree. Then again perform the union, and then we'll see the what is the final binomial heap. So after the merging I got that this is the final binomial heap, and the 15 is become the leftmost children and 6 is become the root, right? And their degree, this tree's degree is what? B4. This tree degree is B4, right? And how many trees, how many binomial tree? Single binomial tree. There is a single binomial tree, because if you count the number of node, total node is nothing but a 16. Total node is 16, and if you convert this 16 in a binary bit, if you convert this 16, you will get it like this. So see that there is a single one, it means that this is B0, this is B1, this is B2, B3 and this is B4. So there is a single one, it means that there is a single binomial tree possible, right? So there is a single binomial tree with a 16 node. So this is the, I have decreased the I have extracted the min, I have deleted it, and then I have to perform the union, and I got this final binomial tree. And the tree is binomial heap, and binomial heap is with 16 node. So how many binomial tree possible? One possible. Now we'll see the time complexity. So this was the given question. It was given that this was the given question. Now what we were doing, we were first step what we were doing, that finding the mean. First is find mean. So find mean, what you are doing, we were checking that all the binomial trees root, and we have already know that in the property of the binomial tree I have explained that how many binomial tree possible inside the binomial heap with n node. So total is log base 2 n binomial tree possible. So for finding the min, the time complexity is nothing but a log base 2n. Log base 2n for finding the min value. Next step what we were doing, so after the deleting 3 we got this. After the deleting, their children become separate. So we were what we were doing, I am arranging this in a valid binomial heap. After arranging we got this one. So for arranging is also taking time log base 2n time. Log base 2 n time for arranging. Third step, after the deletion and arranging, it will take log base 2 n time. And then one is afterward what you are doing, afterward we were performing union method. And in the previous video I have already explained that union is also taking log base 2 n time. So if you sum that all these time complexity, the total time complexity is log base 2 n time. So what we say that extracting the minimum from the binomial heap, the time complexity will be the log base 2n. Why so? Because we were performing 3 steps. First finding the minimum, then after delete the minimum and delete as well as the arranging the binomial heap, arranging their children's, and then third step we were performing the union, and all three is taking the log base 2n time. And if we sum this all time complexity, and according to the time complexity asymptotic notation, the time complexity will be the order of log base 2n. So this is all about the binomial heap and extracting the mean. Now I have just created two binomial heap I have created for your practice purpose, so you can better understand. So I hope that you will try this both question, and just watch that the explanation of the extracting the mean that I have explained. If you are getting any doubt, you pause it and then again watch, then you can understand, and do practice both of them. You can easily, both of the question I have made that both there is a connection here, then you can easily understand that extracting the minimum value. So that's all about this topic, extracting the minimum from the binomial heap. Thank you for watching my video.